All right, so one of the things that we left off on the other day was I showed you guys this, and then I showed you how to cheat using the orbital diagram. Today, we're actually going to do our own orbital diagrams. Sir. Oh. All right, remember there's two things. The first thing is, and I don't know if I wrote it or not. I don't remember where it is if I did. There's two terms that you guys need to know, guys. The first term, wow, where is this? There it is. The first term is the electron configuration. If you see the term electron configuration, what that means is you're going to do the superscript version. Okay, we haven't seen this to a degree yet, but we're going to come back to it. Okay. The other term is the orbital diagram. So what we're going to do first is we're going to do the orbital diagrams. Then we're going to come back, after we do the orbital diagram, you're going to be able to see the electron configuration based off of it. And I promise you by the end of this, you are going to prefer the electron configuration version over the other one. So let's look at this first one. It says, write the orbital diagrams. So one more time on this, when it says orbital diagrams, which version are you working with? No. No. The arrows, thank you. Okay? All right. So we've got the arrows. That's what we're working with. Now, on the sheet of paper that was Spread the Wealth that I gave everybody, if you got your own out, here's what I want you to do. Okay? I got to go all the way back through all this. There we go. All right, so the first thing I always do is I write the letter, the symbol, and then you don't have to do this, but I'm going to show you this the first few times so it'll make sense. What is the atomic number for hydrogen? 1. It's on there. And the atomic number is also equal to the number of protons. So if the atom is neutral, then you'll have how many electrons? 1. Well, that's easy. Okay? So here's what we're going to do. We're going to go ahead and set up the orbital diagram. Now, no matter what element or atom you're working with, either 1 to 118, what is always the first energy level you start with? 1s, okay? So we're going to start here. We've got 1s. Now, how do I draw or represent is a better word. How do I represent an electron in this version? An arrow. How many do I need? 1. But this is important. Which direction? Thank you. And I don't care how you feel about me. I am doing my half arrows. You could jump off a bridge for all I care. That was sad. Get over it. I did. In the water. That's safe. Okay? That's safe. I didn't say how high of a bridge. I just said a bridge. Well, that's your choice. So we've got 1 arrow. So this is the simplest version of an orbital diagram you can have. It cannot get any simpler than that. Now, we're going to talk about ions later on. Remember, ions are when you gain or lose electrons. So, if hydrogen lost that 1 electron, what would it look like? There would be nothing. Okay, there's absolutely nothing. So this is as simple as it gets. So let's turn this into the electron configuration. So instead of drawing all these arrows, so if we did the orbital diagram for uranium, which is 92, you would have to draw 92 arrows, and that would get really laborious really quick, right? You would not want to do that. So we're going to do it in the electron configuration version. So again, this is electron config. So what we do is we take the arrow and we turn it into a superscript. So you write it the same. So it's 1s, but then what do you write behind that? 1. Very good. And that is it. So that is the electron configuration for hydrogen. Any questions? What? You will like this, but let me go ahead and tell you this for how the test is going to be set up. Let's say question 1 says, write the orbital diagram for the following element. You'll have to do the arrows. Question 2 could be like, write the electron configuration for whatever element. So you have to know the terminology to know which version I want. And I'm telling you, if you get the version wrong, I don't care if it's right as far as what you drew, you still lose credit for it. So the terminology is going to be very important here. All right, so the next element is boron. So let's go in and do boron. Okay, next page. All right, what number is boron? Very good, number 5. So we've got 5 protons, which means if it's neutral, you automatically have 5 electrons. Okay. Again, same question. No matter what element, where do you always start? 1s. Very good. So we're going to start at 1s. And I'm going to jump over here to the periodic table to make it look a little easier. So remember, there is something special we have to do with the bed. Remember, we called it a bed. What do we do with helium? Okay, very good. We take it and we bring it from here all the way over here. Don't worry about why, just accept the fact that that's what we do. So we're trying to get to boron. So my question is, am I going to use these two? I got to go through them to get there, right? Okay, so let's get rid of these. So my question to you is, I've got at least to fill up the 1s orbital. How many electrons can fit in one orbital? 2. But here's the all-important question. There's my first one. We've already seen this. If it's 2 electrons on the same orbital, how must they spin? Opposites, which is down. I don't care if you don't like my half arrows, get over it. Okay? Sir? That's a good question. How do I know if it's neutral? We're going to get to this a little later on, and I don't have a really good example, but let's pretend, Jack, that it was, it would look like this. It would be B 3+. This is what it would look like. Do you agree that there is a positive or a negative on this thing? Okay. So, because there's a positive, we know that it's a charge, and we will worry about that tomorrow. Don't worry about it today. Okay. So, for today, it's just regular old B. You good? All right. So, let's go back to the periodic table. And so, my next question to you guys is, what comes after the number 2? The number 3. Well, who is number 3? Lithium. Okay, so my first question to you is, what energy level or what period is lithium on? Okay, so it's second. All right, what block is lithium in? The S block. So the next energy level is 2s. Everybody with me so far? No, definitely write B equals. That way you know what element you're doing. Does that make sense? Okay. But you may want a sheet of paper because we're going to fill up all that space. Okay. Now, my question to you is, how many total electrons do I need? I need 5. Well, how many electrons can fit on one orbital? 2. So what am I going to do? Very good. I'm going to have an up and a down. Well, here's the problem. My question to you is, can I stop? Why? I've got one more. And this is the part where every year, the first time people see it, they kind of like, all right, I don't understand it, but it comes as we do this. So we know that we have just used both of these rows. Okay. Well, what number comes after the number 4? 5, which is where we want to be. However, this is the key part about this. My question to you is, what energy level, what period number are we on? We're still on the second level. Do you agree? Second energy level. However, have we changed blocks? What block have we now changed to? P. This is the question that you must know the answer to. How many orbitals are in each P block? 3. Did everyone know that? You've got to know that. Every P orbital has every P block has 3 orbitals. So here's how I do it. You don't have to do it this way. You can do it however you want. But I'm telling you, sometimes I'm a visual person. And so if I can create an identity visually, it makes make sense to me. So what I do is I put all of my P blocks in brackets. Okay? And you've already told me that I have 3 orbitals. Now, let me figure out the best way to say this. All right, so let me kind of take a step back. You've already told me it's which period number? 2, and you've already told me that it's the P block. Okay. Thus far, we've used 4 electrons. How many do I need to use? I need to use 5 total, 1 more. Okay? So where's it going to go? Far left, which direction? Going up. This is the orbital diagram for boron. But can someone tell me, and this is it. This is what you have to draw. Can someone tell me where you think students might make mistakes in this? The brackets isn't the important part. Okay? Here's the important part. It's exactly what today's just said. People do not draw those other two lines. So here's kind of how I would say this. Let's pretend you have a 4-bedroom home. Okay? You've got your master bedroom, and let's say you've got one kid. If you were trying to sell that home, would you only sell it as a 2-bedroom house because that's all you use? That makes no sense. You would sell it as a 4-bedroom home. So even though you do not use those lines, you must still show them? Yes. You cannot only put what you're using, you must show them even if you're not going to be using them. That is one thing where students do make mistakes. And again, we develop this as we go, and it makes a whole lot more sense. But that is something important that I want to make a very important stance on. All right, so let's turn this into the electron configuration. Okay, so it's going to be 1s, what? 2. Then it's going to be 2s, 2, and then what? Very good. 2p1. And that is the electron configuration for boron. Cody? All right, that's a good question, and I'm not going to give you the answer you're looking for. Here's what I want you to think. The S is a region or an area on the periodic table. What does the letter S stand for? Socks. Okay, sorry. I thought you literally meant what does the letter S stand for chemically. The silly. Okay. Is that more important than this? Go. Huh? Yeah. Okay. So, what's the next one? Help me out. Sodium. All right. So, I'm actually going to do this one on the periodic table so you can actually see it as we go along. So, sodium is number 11. Again, you don't have to do what I do want you to write the letter Na so you know what element you're doing. But we've got 11 protons, and if it's neutral, what do you have? 11 electrons. Again, the same question I always ask at the very beginning. No matter who you're dealing with, no matter what element it is, you always start where? 1s. Very good. Okay? Am I going to use both of those electrons in that orbital? Yep, because that's hydrogen and helium. They're gone. So we're going to go up, and we're going to go down. Everybody good there? No? Okay. All right, so let's move on to the next one. What's the next energy level that you have to fill? Okay, so we've got 2s. Am I going to use both of those? Yep, so we're going to go up, and we're going to go down. So that uses those two. All right, well, what's the next energy level that you have to fill? 2p. Again, you don't have to use the brackets, but like I said, I'm a visual person, so I like them there. Yes, you do have to use the 3 lines. Okay? Yes, only when it's P will you have 3 separated lines. Like I said, the brackets... Hold that thought. Don't get there yet. I want to kind of build. We are getting there, but hold that thought. Now, so my question is, Caleb, what's up, dude? Okay. So my question to you is, am I going to need all of those orbitals? Yes. But before I go any further, there's that rule that we have to abide by, and that's Hund's rule. And Hund's rule states 2 things. Number 1, you must fill empty orbitals before you double them up, right? So what that means is, when you do this, if I've got one here, where does the next one have to go? The next thing. And the second part of Hund's rule states is if they are by themselves in the same energy level, they must all have the same or opposite spins. What I'm fixing to do, they got to have the same. So it's going to be up, up, up. All right. Am I... Okay. Yes. Yeah. You can go ahead and go right through it. I just want to show, I want to be very specific because we're going to get to one in a minute where it's not full, and I want you to know what you're doing. Okay. So we've got to go up, 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 and then I'm out of empty ones. So then what do? Come back to the very beginning, and they spin opposite. So down, down, down. Now what Grayson was saying was, he said, if you know that's going to be full, do you have to go up, 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 and then come back? No, if you want to go ahead and do it, but don't get in that habit. And that's the part that I don't want you guys to get in. All right, and the last one. So we're finally at sodium, which is number 11. So it's the next energy level. So the first question is, what is the energy level number? What period are you in? 3. What block are we in? S, and there's only one line, one orbital. And how many arrows do I need? 1. Everybody good on that? Any questions? Okay. Any questions? So you, by yourself, okay, Kyron, go ahead. Hold that thought. Nope, don't even ask that question. We'll come back to it. You, by yourself, turn this into the electron configuration. And then I'll write it after you have a chance to do it. All right, let me answer this question out loud because it's a good question. I'll come right back to you, Josh. What the question was is, how do I always know what's next? And this is really what it is. We're counting on the periodic table. Okay, so we knew I had to get to number 11, right? Well, to get to number 11, you got to go 1 through 10. And we know that if I start at 1, that's the first energy level in the S block, 1s. Okay. Well, there's 1 and then there's 2. Well, I can't put any more arrows on that one, so I got to go to what comes after 2? Number 3. All right. Well, number 3, which is the third arrow, right, is in the second row, S block. Okay. Well, that's 3 and 4. So 1, 2, 3, 4. You with me? Well, when I go to my fifth one, my fifth arrow, notice where it is. It's in the 2p one, right? Okay. Well, that's because it's on the second row and in the P block. So what you're really doing is you're just counting all along the periodic table. So how did I know to stop at 3s with 1 arrow? Do you agree I'm trying to get to sodium, which is number 11? Okay. So after I go all the way 1 through 10, sodium is on the third row, S block, first element. You see it now? Really, and that's when once that light bulb clicks, this becomes super simple. Okay? All right, so the electron configuration that you guys should have gotten should have been 1s2, 2s2, 2p6, 3s1. Is that what everyone got? Okay, everybody good? All right, what's the next element on the sheet? All right, here's what I want you guys to do. I want to see if you can do the electron configuration. And again, what version is that? The superscripts. Okay? I want to see if you can do it without the arrows. I want to see if you can do it for sulfur. See if you can do it without the sulfur. So let me explain something to you. The easiest way to do this is to imagine you're writing those arrows, but instead of doing up, down, up, down, up, down, what can you write? Just write a superscript. Okay? See if you can do the electron configuration for sulfur without the arrows. All right, so here's the answer. If you're not quite finished, just keep working on it. Remember, bottom line, doesn't matter what element, you always start where? 1s. And again, we're doing sulfur. So in the end, I should have 16 of these. So I always start with 1s. Now, how many are always in the 1s? 2. So that takes care of hydrogen and helium. So 1s, 2. All right, so let's move on to the next one. What comes after the value of 2? 3. So that takes me to lithium. All right, well, that's going to be 2s. Do I use both of those? Yep. So let's make that a 2. All right, so let's come over here to the next energy level. Okay. What period is that? That's 2. What block? P. And am I going to use all of them? How many? 6. Very good. Okay, after I've used all of those, I come down to the next energy level. What comes after? So sodium is next. What row? 3. What block? Am I going to use both of them? Yes. And the final one, because sulfur is in this next energy level, what row? 3, what block? P, and what number? 4. Let me tell you where I notice students making mistakes. And guys, I've been doing this long enough to know where mistakes happen. What students do is they take helium and they move it over here, and this is the mistake they make. They start this as 1, and that is 2. Now, remember what I said. You just have to mentally move helium. But is it still in the first row? Yes, okay? So again, that's a big mistake that I see students make. This is not right. It's 1, then 2, then 3. Okay, so again, make sure you kind of catch on to that aspect of it. Any questions? So far, which version do you prefer, electron or orbital? So, and I always hear that. I hear people say, I prefer the arrows. The reason why is because it's concrete. You can touch it. You can see it. This is a little more abstract. Okay? Eventually, you're going to get tired of the arrows, and you will get to this. This is why I always do those half arrows, because I hate drawing, and I don't draw arrows really well. But that's besides the point. I really don't. Which one? That is an awful arrow. For me, it's actually pretty good, but it's still a bad arrow. But again, this is kind of where we want to. This is what we want to do. All right, I want to do one more. I want you guys to do one more. Do calcium. Okay, there's a reason why I'm stopping at calcium. See if you can do the electron configuration for calcium. And I'm still full throttle. All right. So, we're doing calcium. So no matter where we are, we always got to start the same place. We've got 1s, 2, takes care of those. 2s, 2, takes care of those. 2p6, that's all of those. The next one is going to be 3s2. That's done. 3p, and I'm going to use all of them, so that's 6. And then finally, the last one is going to be 4s, and how many? 2. Very good. Any questions on that? All right. Now, here's the next thing I need to show you. What I'm fixing to show you is a lazy version of the orbital diagram. Please, please, please do not do this. I'm doing it simply because I'm lazy, and I'm going to do a mesh of a hybrid of it. So here's the one we're going to do. We're going to do iron. So go ahead and write this down. So we're going to do Fe. Okay? So let's do what we know thus far in the electron configuration version. Okay, again, this is nothing real. We're making this up, but I'm too lazy to draw all those arrows. So this is what we're going to do. We're going to pretend like it's the electron configuration, and then we're going to convert to the orbital diagram when we get to the point I need to show you something. So again, no matter where we start, where do we always begin? Okay, 1s, 2. After that, 2s, 2. And again, you'll get to the point where you can say it just as fast as me, and you can go all the way through this entire thing. So 2p6, 3s2, 3p6, 4s2, and I'm going to stop there. Because that's as far as I can get. Because, actually, did I move that? Do you agree that this is calcium? It should look identical to calcium. The one I currently have written. Hold that thought for just a second. Nope, I don't have a D yet. So let me write this a little more proper. So this is 3s2, 3p6, 4s2. Ignore the fact this is iron for just a second. Let's pretend that this was back at calcium, because this is exactly what you wrote for calcium. Do you know how simple it was when you guys saw those arrows, that all you had to do was count the arrows? Remember, what we did is we converted those arrows to what form in this? Superscript. So, if you want to double check your numbers in your math, if you will add up all of the superscripts, it should be equal to the element you're trying to find. So, what is 2 plus 2? What is 4 plus 6? What is 10 plus 2? 12. What is 12 plus 6? And 18 plus 2 is, that's exactly what you needed. So, there is still a counting double check method. You're just not counting arrows. You're adding numbers. This is the D block. This is what we're fixing to do. Okay, this is why I stop here. So here's the next aspect of this. We're not finished. We're not finished. What I want, we're doing iron now. But the reason, if I did the orbital diagram, it would have taken a lot longer, a lot more space. So I'm going to mix and I'm going to do the hybrid. Here's the reason I'm showing you the next version is because I need you to be able to do it the orbital diagram version. Now, we know that every P block, and again, I'm talking about the P block, has how many orbitals? And when I say orbitals, I'm really just referring to the lines. How many lines does every P block have? 3. Well, let me ask you this. How many electrons can fit on each line? 2. So, if you've got 3 lines and 2 arrows apiece, how many total is that? Well, let me ask you this. If I've got that many, how many elements are in each P row? There are 6. Well, let's translate that to the D block. Does anyone know how many total elements there are in the entire D block? There are 10 of them. Same concept. If you've got 10 elements and you can have 2 on each line, well then how many lines do you need? You need 5 lines. So this is what you then have to do. You need 1, 2, 3, 4, 5. 5 lines. So to continue the trend, and let me, before I say this, this is a disclaimer. What do you guys know about the F block? Don't worry about it. Forget about it, right? But I want to say this. If we had to do an F block, how many lines do you think it would need? It would need 7. And the way you know that is, way down here, these 2 bottom rows, how many is in each row? There are 14 of them. Don't worry about it, but you can see the trend, okay? The P is 3, the D is 5, the F is 7. But we're not getting anywhere near the F block. All right, because it's really complicated and confusing. Just trust me on that, okay? It is, and it's a lot of arrows. Everyone always remembers the 5. That's the easy part. The challenging part is, and you only remember it with experience. And if you watched those videos yesterday, you should have caught this. There's something weird about how you start with the D block. Instead of it looking like it starts at 1, 2, 3, 4, which is where it looks like it begins, what do you do to the value of the energy level? You change it up 1. So even though it looks like it begins on 4, it's technically what? 3D. Now, that is the one part every year that when students get into the D block, they either get it or they don't. And the only way you can get this right is by practice, practice, practice. That's the only way you can get it right. Okay? So since we now know which energy level we're in, which block we're in, now we've got to figure out what orbital we're on. Okay? And Grayson, this is why I said a minute ago, I teach it in a specific way. So because of Hund's rule, we know that before we can ever double electrons up, what do you have to do with them? You've got to separate them first, right? So we're going to start at the far left, and we're going to be spinning up. So that's 1. Now, what number is iron beginning in the D block? It's the 6th one. So we're going to go up is 1, 2, 3, 4, 5. I'm out of room. What do I do? Go back to the beginning and do what? Go down. So this is the orbital diagram for iron. Any questions? Here's the deal. If it's an orbital diagram, I'm not going to make you do 35 arrows. Okay, it'll be the smaller ones. Let me go ahead and say this, and I don't want to say this out loud too soon, but there is it's a good way to say it. It's modified, but it's really a shorthand version of all of these, and I'm going to teach you that tomorrow. Okay? Because instead of writing, like, do you agree if you had to do 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4D10, 5P6, 6S2, 4F14, 5D10. That gets a little cumbersome. There is a modified version that you can shorten it up that you will at most only write 3 variables. And what I mean by that is like 3 parts. Well, I'm going to explain where you start at. The noble gas configuration. Okay. Cody, go ahead. Do you want to do the whole thing? Or the electron configuration for it? Okay. Now, yes, but let me do this real quick. If I wanted to convert this thing that's circled in orange, if I wanted to convert that and add it to the electron configuration, what would it turn into? 3D6. Very good. 3D6. That would be what you would convert that into. Okay. All right, so since Cody requested, Cody, I'm not going to let you do scandium. I'm going to ask you to do vanadium. Do V. Vanadium. Just do the electron configuration. If you want to do orbital, go ahead. But I wouldn't draw those arrows. Nope. Okay. All right. Again, this is vanadium 1s2, 2s2, 2p6, 3s2, 3p6. And then it is, that's the wrong button. 4s2. And finally, the last value, again, would be right here. 3d, 1, 2, 3. 3d3. Okay? Cody, let me ask you this. Did you put 3D3 in front of 4S2? Okay, here's the reason why. Cody, and this is a great question, so everyone needs to catch this. You're telling me you eliminated that, right? Remember how I told you could double check to see if your answer's right? You would be too short. And the 2 short that you missed were potassium and calcium. You left out 19 and 20. So mentally, I'm glad you brought that up, because that's what you kind of need to do is say, all right, in the very end, does my number of exponents add up to be whatever I'm looking for? And if it doesn't, then something's wrong. Either you didn't write the right exponent or you left one out. Okay? All right, what's the next element on y'all's sheet? Krypton. All right, that's a good one. So let's do what we know. So again, we're going all the way over here to 36. So where do we always start? Okay. Again, we're doing krypton. So it's 1s2. All right, that takes care of hydrogen and helium. The next one is what? 2s2. That takes care of lithium and beryllium. Then we got to come over here to the boron row. That's going to be 2p6. That takes care of all those guys. Coming to number 11, that's going to be 3s2. Takes care of those 2. Then we got to go to am I going too fast? Okay. Okay. So we've done sodium magnesium. We should have 12, and we do. Now we've got to go to aluminum row. That should be 3p6. Now you guys keep going out. I got to come down because of space. So that takes care of those guys. Then we've got the next row is going to be 4s2. That takes care of that. And so far, we should have 20. And if you went back and counted, you should have 20. Okay? What's up, man? You teach some electron configuration? Okay? So, key part. What's after 4s? 3d, how many? 10. And then you've got to get into the last row. Because remember, right here starts to P, and it's how many? 4, P, how many? 6. All right, I know I kind of went through that real fast. Here's the part where students mess us up. It's this number right there. After 3D, they want to keep it at 3P, but had you already written that? You can't rewrite it. Okay? Only the D block has moved up. Any questions? Is there one more on there? What's the other one? There's two more, right? Do the last two by yourself, and I'll draw them up there. Chromium and phosphorus.